What did you say? So every graph, all sine and cosine graphs by default, they hover around a midline that is x or y equals 0. So whatever you're talking about, I'm sure it's awesome, but be done now. Okay, thanks. So this red line is the graph's we call it a midline. It's the line that the graph goes equally above and equally below. So in a problem like this, the first thing we want to do is we want to shift the actual midline down too. And you'll find from this point on, pretty much graphing the midline, even if it's just a light sketch, just having it there is going to help you a lot. So the first thing I'm going to do is grab the midline and I'm going to move it down 2. So there is the new midline. Now, what that means for us is that the cosine graph is still going to, do you need help? What's the matter? What are you guys looking at?
We just see if there's rulers back there.
Oh, you need a ruler? I can pause this and get you one. Hold on a second. So there's our midline. And now what we're going to do is we're going to graph the cosine. Now, what helps here is just to have some perspective. You really should probably pay attention now. You want to know, first off, and this always helps with trig graphs, is just to go back and think about the default cosine. First off, is cosine a start on the midline graph or start away from the midline? Cosine's a high starter, remember? And we know this from either from Thursday or from our experience with the circle, that cosine begins his journey up at 1. So in this case, because the amplitude is 4, then we're going to start the cosine journey at 4 units above the midline. So ordinarily, if it weren't for the amplitude adjustment, the cosine would start right there. I'm making a little purple circle. We don't want it to start there, though, because the amplitude buffs every vertical thing times 4. So the actual starting point for this cosine graph is 1, 2, 3, 4 units above the midline. Again, this is all based off of what would be happening if it were not for what we call the transformations. And so the -2 is a vertical shift transformation that just physically moves the whole graph down. And then the 4 buffs all the highs to higher and it buffs the lows to lower. Okay. Now, when we get to pi over 2, let's do that one first. What would the cosine normally be at pi over 2? It would be 0, which means it's going to hit the midline. And so I don't need a multiplier for this one. In fact, the amplitude of 4 has no bearing on this particular point. If we know, if we know that the cosine of theta, when theta is pi over 2, if we know that the cosine is going to be 0, 4 times 0 is 0, the graph will hit the midline at this point right here. And we'll fill in some tweeners after this. We'll get the pi over 4 and 3 pi over 4, but let's fill in the quadrantals first, because I think they're the easiest. When we get across to pi, what would the normal cosine be? -1, but we have to buff it times 4. So it's going to shoot 4 units down, 1, 2, 3, 4 units down below. What's that red line called again? I keep saying it. Midline, good. So midline is your buddy. The midline, as he moves, the graph stays symmetric like it used to around the x-axis. You just kind of essentially are making a new x-axis. Let's head over to 3 pi over 2. So 3 pi over 2, remember, is the bottom of the unit circle. What would the cosine be there? 0. And so it's going to be on the midline right here. And if you're wondering, like, why are we not putting the point on 0? It's because the midline has shifted down. That vertical -2 at the end tells us that all points will be shifted down, right? So instead of 0, it's 0 - 2. Are you good? Okay. Let's head over to 2 pi. At 2 pi, what's the cosine? It's 1, but we have to multiply it by 4 and buff it 4 units up above the midline, which is going to put it right back up here with its homie right there. And then we'll just go. Basically, a good rule of thumb is when someone gives you a graph, just kind of graph it until you run out of graphage. So we can go 2 more iterations of this process. So we're at 5 pi over 2, which, as you know, just means we're back to the top, right? We're coterminal with an old regular pi over 2. What's the cosine there? You don't have 5 pi over 2 on your unit circle. So let me, I'm not going to pause this. Either you're giving me the silent treatment or I need to do something real quick. So I'm going to go with the assumption that you need an explanation. This is the unit circle right here. And if you're right up here, you are at pi over 2, correct? However, let's be perfectly clear. That is named pi over 2 when you have gone this far, correct? Now, follow the purple arrow and continue on. So there's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, and presto, there's 5 pi over 2. So what I'm trying to get across to you, and maybe you know this and you just didn't want to talk to me, those are, again, are called, we've said this word before, those are called coterminal angles. And so when I ask you for the cosine of 5 pi over 2, I'm really just asking you for the cosine of 1 pi over 2, because that's the same relative stop or location on the unit circle. So what is the cosine at 5 pi over 2? It is 0. So 2 then, I mean, we just have to shift it down 2. So we're right here. And then finally, where is 3 pi on the unit circle? Describe that to me.
3 pi?
Yeah, it's pi. Right. You just keep pulling out chunks of 2 pi. So it's this idea of, you know, where we have excess. If you go all the way around to the right side, or in your case, the left side, sorry, that's pi. And then if you go all the way around again, that's 3 pi. What would it be if I went all the way around again? 5 pi, exactly. Go all the way around again. What do you get? 7 pi. So we're just working in multiples of entire unit circles here. So 3 pi is just the same place as 1 pi. The cosine there is -1, but we buff it to -4. And this is what our graph should look like. If you haven't figured it out, moving the midline is a pretty important thing because it's why we're able to put points above and below based off of the amplitude. They work together like that. And then to complete this graph, you really have to make it official and get in and draw the curve such as this. Sorry, it's not beautiful, but it'll do like that. So good. Yes.
I did not get this paper. No.
Yep, it's right here. So that was question 5. Does that, anyone who wanted to go over that, does that help to clarify what we're up against here? Okay. Oh, Brady, can I help you with something?
So on the first one, you know, it's 4 sine. And sine starts at 0. Do I go up to 4?
Where are we at?
On the first
The very like problem 1. Oh, wow. Oh, no, 0 never changes from 0. What upward times 0?
Oh, so it's multiplying that.
Of course, if I wanted to add, it would be a plus on the other side. You got this one?
Yes.
You want to pick or do you want me to?
Thank you.
And then you can just tell me which one you got. So the first thing you're going to want to do is shift your midline. So the midline is the horizontal line that the graph snakes around. Cooper, I just saw you perk up. You're going to start following along, aren't you? Yeah. Good. You should. So this one has, so assuming you've done the first page, you understand that what the 2 in the front does is it modifies, turn around, Brady, it modifies the amplitude. So it makes your highs higher and your lows lower, right? But the -2 at the back, what it does is it modifies the symmetry line. So all sine and cosine curves are symmetric about a horizontal line. By default, until we have a reason not to, they all go around 0. So that's just, I mean, they start, you know, they go around, they go above it, they go below it, they go above it, they go below it. The -2 at the end very simply says to take this and move it down 2. So the midline is now lower. Whatever that says at the back is where your new essential, I'm going to say like home base is, if you will. Okay, so now we build essentially from that line. Like we're no longer referring or talking about things relative to the x-axis. This is like our new x-axis. So where does the sine curve normally start? Is it a start on the midline or above it? Sine starts on the midline because sine of 0 is 0. And so when we multiply sine of 0 by 2, we still get 0. So this curve is going to start right here. Are you with me so far? But again, it's all relative to the midline. He's our new x-axis. The old x-axis is dead to us, right? Because we moved down. So at pi over 2, what normally would be the sign? 1. But the 2 in the front, and I'm going to point to it, this 2 tells us to double everything that we've memorized on the unit circle. So the unit circle now is quick, right? We know sine of pi over 2 is 1, but the 2 that I'm pointing to with those arrows says double that bad boy. And if you double 1, you get 2. So our second point is 2 above the midline, which is right where I put that next purple dot. It's not up at 2, it's 2 above the midline, right? And then we're back to pi, and at pi, what's the cosine or the sine? We're back to 0, and double nothing is still nothing. So we're going to come back to our buddy, the midline. This distance right here, let me draw a little arrow for you. This distance here, that arrow represents, is called the amplitude. The highest the graph goes is 2 above the midline. Therefore, the amplitude of the graph is 2.
So
And then when we get to 3 pi over 2, the normal sign down at the bottom would be -1. If we double that, we get -2. And again, if someone were to say that's -4, then I'd say you just haven't been listening. It's not about that. It's relative to the midline, right? It's 2 below the midline.
we move on like again 2 pi over 0. as well.
Yeah, so like you can already see the pattern emerging, and that is that we're going to go back to 0. We're going to go 2 above. We're going to go back to 0. Like once you understand how the pattern looks, then you could do this all day long. And then to make the curve, you do not want to do, don't get Kerpensky on me and graph it like this. Like this will get you, I'm sorry. You didn't deserve that either. So we want to try to make it look curvy. Thank you so much. So I would say go to your highs and lows maybe, just to encourage curviness, and start with making some curves. And that almost like forced the issue. And even that, I'm not very proud of what I just drew there, but like this. So I wouldn't complain too much, but I could have done better on those 2 segments right there. So you guys good?
Yeah.
So step 1, move your midline. Step 2, build graph based off the midline.
It's really hard.